there are a handful of special right triangles, and I'm going to keep repeating the word right triangle in there because it's important to remember these things only apply if we know or we can conclude that the thing is a right triangle. If we don't know that for sure, then we can't use these special rules. Now, if we know it's a right triangle, okay, one thing that's not mentioned right here, this is just taking us back to school days here, is the Pythagorean Theorem. Pythagoras was a Greek mathematician, and he came up with the idea this only applies for right triangles, so remember that. But if we know it's a right triangle, then the length of one side squared plus the length of the second, shorter side squared is going to be equal to, in the ideal case, this is the longest side, which is called the hypotenuse, squared. That's handy. Now, one special right triangle, I call them magic triangles, that exists in nature is a triangle that has sides in a ratio of 3 to 4 to 5. That's very useful. That doesn't mean every triangle, but if we know it's a right triangle and you tell me that the sides are 3 and 4, then I know with certainty that the third side is a 5 because it has to be. It can't be anything else if it's a right triangle. Remember, notice this, in a ratio, when it's written properly, it has to go from least to greatest, 3 to 4 to 5. Another magic triangle is right below here, 5 to 12 to 13. That's going to be a tall, skinny triangle. Again, the longest side is going to be opposite the largest angle. Well, that means it must be opposite the 90-degree angle because you can't have an angle larger than 90 degrees. So from the definitions of triangles, we know a lot already. If they just throw us a bone, if they give us one measurement, we might be able to solve the entire triangle based on what we know, and then adding to that what they tell us. That may put us in good shape to solve the entire thing. So again, a ratio can have as few as 2 elements. It can be like 1 part rice to 2 parts liquid. That's a ratio. We use ratios all the time in recipes. But a ratio could have many elements. It could be 1 to 2 to 3 to 4 to 5 to 6, whatever. But it always has to go from least to greatest. That's useful because so many of the questions in the GRE in math are simply inequality questions. Which quantity is greater? You don't have to know what the value is to still know that by the rules it has to be larger than that other number, whatever that is. So, that's worth knowing. So one of the special magic right triangles is the isosceles right triangle. That's from the Greek, iso meaning same and skeles meaning scale. This is a triangle with sides 1 to 1 to square root of 2. Okay, since we know it's a right triangle, then we know if one of the angles is 90 and the other two are equal to each other, they have to both be 45. And those angle measurements correspond to the length of the sides, 1 and 1 and square root of 2. Now, don't let them trick you into making this more complicated than it needs to be. Square root of 2 is nothing that you need to mess with. It's just a value. Just think of it as if it were x or as if it were pi. You don't need to do anything to it. You're talking about how many square roots of 2 are we dealing with. And so in this base case, it's understood that this is 1 times 1 to 1 times 1 to 1 times the square root of 2. And you don't need to know it, but the square root of 2 is approximately equal to 1.4. 1.4. All you really need to know is that it's greater than 1 and it's less than 2.